Welcome back to The Explainer. So today we're unpacking a really wild, super practical experiment by Samarveer Singh over at XDA Developers. Basically, he decided he was completely done with traditional scheduling and handed his entire daily routine over to a local large language model. It's a fascinating journey, and we're going to explore exactly how he built this, the unexpected hurdles he hit along the way, and how it completely transformed his daily productivity. Let's get right into it.
I want you to think about your own schedule for a second. Is your calendar basically just a giant, guilt-inducing list of commitments? I mean, sure, it probably knows exactly when your 2 p.m. meeting starts, but let's be honest here. It doesn't have a clue when your cognitive energy is actually peaking. It doesn't know what you can realistically squeeze in before lunch, or when you're simply demanding way too much of yourself. Traditional calendars completely fail to track your productivity flow, or really the actual shape of a human day.
And this is exactly where we run into what I like to call the daily chaos mix. Outside of a few fixed commitments, like a daily business stand-up and a couple of gym sessions, Samarveer's days were technically wide open. But having a wide open day can actually be a trap. He had to juggle heavy writing blocks, respond to customer PC build requests, handle meal prep, and ideally find a little time to relax with his PS5. Because there was absolutely no real structure beyond his fixed meetings, important stuff just kept getting pushed to tomorrow. Sound familiar at all?
All right, let's dive in. Here is our roadmap for today. We'll start with the core problem of standard calendars, tackle the surprising architectural and API hurdles of building an AI solution, host a technical showdown between 3 local LLMs, and finally, reveal the massive and honestly pretty hilarious daily impact this had.
Section 1. The problem with calendars and the vision. Moving beyond generic productivity templates.
Moving right along to Section 2, Architectural and API hurdles, earning the right to automate.
Okay, so the grand vision here was brilliant, but it definitely required some heavy lifting. Samarveer wrote a vibe-coded Python script, which essentially means he let an AI write the code for him based on a prompt. The goal was simple enough: take a basic Notepad task list, complete with estimated durations and priorities, and pass it directly to a local AI model using a framework called Llama CPP. But here's the crazy part. Getting the AI to actually talk to Google Calendar was surprisingly harder than running the LLM itself. He had to navigate this absolute labyrinth of Google API menus. You have to create the exact right credentials, dot every I, cross every T, and make sure you don't click the wrong button before finally downloading the required JSON file. It's the kind of tedious, mind-numbing scription that makes you very, very glad you only ever have to do it once.
So, the API is finally connected, the LLM takes the wheel, and boom, immediate roadblock. The LLMs kept moving his fixed events. You see, Samarveer told the models that his morning cardio and daily business stand-up were absolutely immovable, but the AI just couldn't help itself. To make the schedule look neat and tidy, it tried moving these completely immovable objects. It turns out you literally can't just politely ask an LLM to respect hard boundaries.
Which brings us to a massive developer lesson. To quote the source directly, anything that must be true should never be left to an LLM to interpret. That right there is absolutely crucial. A prompt can request a restraint, sure, but to truly enforce one, code has to step in. Samarveer had to actually modify his Python script. The new script architecture locked those fixed events safely into place. It mathematically worked out the free gaps between his fixed meetings and then only allowed the LLM to schedule tasks inside those specific vacant spaces. If the LLM tried to color outside the lines, the Python script flat out rejected it.
Section 3. The local LLM showdown. Finding the perfect AI for the job.
Let's look at the hard data here. This was tested on an RTX 4070 Ti, a Ryzen 5 7600X, and 32 gigs of RAM. And we see this really fascinating split. Qwen3 8B generated at 74.4 tokens per second and finished the entire schedule in an astonishing 3.3 seconds. Qwen 3.59B was right there in speed, but took 15.4 seconds total because its outputs were a bit longer. And finally, GPT-OSS-20B generated incredibly fast at 95.5 tokens per second, but actually took the longest total time at 26.6 seconds. But listen, as we're about to see, raw speed does not necessarily equal a well-planned day.
Let's check out the actual qualitative differences. Qwen3 8B was the fastest, yeah, for sure. But it completely failed to put meal prep into the calendar. Being fast is completely useless if you forget to eat, right? Now, the 9B model was highly competent and did a really great job. Meanwhile, GPT-OSS-20B was the slowest of the bunch, taking about 11 seconds longer than the others. However, and this is a big however, by using a setting called No Map to bypass standard memory mapping and load the model entirely into system RAM, those extra 11 seconds of processing resulted in a vastly superior structural logic for the whole day. The real reason GPT-OSS won a permanent spot on his machine is because it completely eliminated something called task whiplash. That's that exhausting experience of working intensely on a PC for 3 straight hours and then suddenly having to sprint to the kitchen to chop vegetables. GPT-OSS smartly grouped related activities together, creating this natural, logical flow that actually protected his mental energy throughout the day.
Section 4. Discoveries and Daily Impact when AI deletes your video games. So, an incredibly funny pattern emerged during testing. The AI had very, very strict priorities. Writing? Yes, absolutely. Meal prep? Done. Customer requests? Scheduled. But all 3 models universally swept his gaming time right off the edge of the schedule. At first, Samavir thought the local LLM was just being hyper-productive, basically deciding that the PS5 was clearly the least essential thing in his entire life. But this brilliantly illustrates how AI only knows exactly what you tell it. Samavir realized he had artificially set the end of his day in the script to 9:30 p.m. But in reality, he usually has free time until around 11:30. He was basically forcing the models to cram his entire life into this artificially tiny window. By simply extending the day's boundaries in the code to 11:45 p.m., the AI finally had room to breathe, and magically, gaming found its way right back onto the schedule. He essentially had to stop sabotaging his own calendar for the AI to do its job properly.
So what is the ultimate payoff here? It's honestly a total lifestyle shift. By running this script every single morning with GPT-OSS-20B, there is zero morning planning fatigue. None. The calendar is no longer this dreaded list of obligations. It's a dynamic, custom map of the day. Samavir set up an automated widget on his phone's home screen and keeps the calendar open on a second monitor while he works. This provides constant, effortless accountability without some nagging productivity app pinging him. The day is completely mapped out, and all you have to do is just follow the instructions.
I'm going to leave you with one final thought today. Are you ready to hand your mornings over to a local AI? When you combine the rigid, hard-coded logic of a Python script with the intelligent, nuanced task grouping of a 20 billion parameter model, you don't just get a schedule, you literally get your peace of mind back. Thank you so much for joining me for this explainer. I highly encourage you to think about how you might be able to automate your own daily chaos. See you next time